Hello. This video is going to be a list of several tips that I found to be helpful in my journey to being a better programmer. Now, it's important to remember that programmers are extremely opinionated and emotional with regards to those opinions. They think that well, let me just say this. We all think we're like the smartest and we have the best ideas that are most justified by real world use or by some form of argumentation. And I just want to put a disclaimer out there that I'm not super attached to any of these opinions. They might change, they might be totally wrong, but that's okay, as we are a safe space for negativity in this channel. So please bring on the little pushbacks, bring on the contrarianism. I welcome it. And yeah, without further ado, let's go to our first tip. First tip is work backwards. So what do I mean by work backwards? Well, this can mean a lot of things to a lot of different people. It could mean writing out your list of requirements, very detailed upfront. It can mean some form of test-driven development where you start by writing your unit tests or something. But I mean something rather more related to the order in which you attack problems in your code. So by that I mean most code is kind of structured with one root main function, and then this will call another function, that'll call another function, and it kind of ends up like a tree that gets executed in some sort of like post or pre-order or something. But when you write the code, oftentimes I see people write the code starting from the bottom layer of the hierarchy. So I think about helper functions and small little functions, data structures or methods for a class or constructors. And I'd like to say that for this tip, by working backwards, I mean we start with the highest level in the hierarchy. So we start with the main function. What do we need in the main function? Well, we need some kind of maybe event loop. Okay, so we start with that. And I like this method of programming a lot better than starting with your little helper functions. Sometimes you need them, of course. Sometimes you need some simple data structures like a vector or something. But point is, I find it a lot more productive and efficient to start with the problem and then divide into subproblems instead of trying to skip to the most basic subproblem. So that's the first tip. Work backwards. All right, second tip. This will be a collection of tips. Understand trade-offs and wait. So what do I mean by wait? Well, in RPGs, this is kind of a silly example, but in RPGs, you can't carry an infinite amount of stuff. Part of that is that the game designers want you to, have that added challenge of deciding what to keep and what not to keep, because things will slow you down. Things will be a negative return on investment. So what I mean by this wait concept is, and we'll see the wait concept again later, you have to understand the cost of adding a function, of adding a file to your project, of putting in a build system, pulling a library. Pulling a library can be the most insidious weight that you wouldn't expect to have to carry, but you never know sometimes when these things come back to bite you in the future. So it's one of those things where you have to understand the trade-offs between complexity and simplicity. So ultimately, we want to be simple, right? We want to be lazy. We don't want to be too clever. And why is this? This side can often appear appealing to the novice and the experienced programmer alike, because you feel like you're able to solve more problems. You're able to solve problems better somehow. The problem is that sort of level understanding that you have to understand the complexity of your program is something that carries with you when you're programming. So when you're programming, the more complicated stuff you're working on, the heavier mental toll that is, and the harder it is to actually like program for a longer period of time. So it's sort of almost like a mental stamina thing. And I want to talk more about laziness. Laziness itself, can be a spectrum. So talk about the laziness spectrum. So spectrum or trade-off, laziness, right? They say a good programmer is a lazy programmer, but I'd like to push back a little on that and say that there is a world where you can be too lazy and it can come back to bite you. So on one side of the laziness spectrum, say the positive side where you're super lazy, you never write any code yourself, you just pull libraries for everything. And this can be tempting because you don't have to actually do much work or thinking. You can just glue together some libraries with Python and call it a day. This side, you have reinventing the wheel. And it's a common engineering phrase to say, don't reinvent the wheel. But that phrase in itself is pretty misleading because, well, how do you improve the wheel? How do we get Lamborghini wheels from the original rock wheels that the cavemen used? There's something to be said, and a great deal of respect I have for people who take it upon themselves to reinvent the wheel, even if they don't improve the wheel. Just that act of putting it or taking it upon yourself to do something that someone else has done, that takes some, I would say it takes some courage, because you want, it's almost like you want to be that guy, you want to be that caveman who first found it. You want to sort of follow in the footsteps of your peers, or your forefathers, and I think that's a really sort of underrated mental state to be in, to be really try to like walk the path of people who came before you. So I think that's great. And also, again, like repeating what I just said, we want to improve wheels. We can't just stagnate. So this spectrum, this tension is really quite interesting because there are dangers to pulling libraries for everything. The most obvious ones are like, what if the library gets deprecated? Then what do you do? What if the API changes? But oftentimes, libraries are actually insufficient for your specific problem. You might pull a library that you think is going to solve your problem, but it doesn't quite solve your exact problem. And then now you're trying to wrangle the library. And that can be an incredibly taxing sort of undertaking to try to wrangle a library. You have to like email, like worst case, you have to like email the maintainers to try to add a new feature or fix something that they haven't fixed. But if you've written it yourself, then there's none of that. So there's some tension here. So for example, one area in which you almost always want to pull a library is there's some complicated math going on. Like it's not always worth it to, or some extremely optimized math going on. It's not always worth it to try to pull that, try to create that yourself. All right. And just to go back to this concept of weight, I'm making a page. Everything has weight. Every line of code has some weight. Every function, every block. Now, you might not believe this because, well, I mean, you can just delete a function that you don't need, or you can delete a variable. It's not exactly the end of the world, but it all adds up. And this is something that you sort of have to just experience firsthand. Navigating through a large code base, trying to understand what stuff does what. And the difficulty in this is more stuff makes it exponentially harder to understand what's going on in your code. So be very aware that every line of code has a maintenance cost, it has an understanding cost, it has a cost. And that cost is additive, and in some cases it can be multiplicative and exponential. Just be very careful about everything you do is going to eventually come back. And this may be something that you might not experience in small projects, but once you get sort of past the threshold, then it really starts to matter. Like the little things in your code really start to add up. All right, spent a little too much time on that tip. But third tip is object-oriented programming. Carries a ton of hidden weight. So what do we mean by object-oriented programming? We mean inheritance. Okay, so I don't want us to get confused here. Objects themselves as just clumps of data, perfectly fine, almost necessary. Well, there's nothing wrong with that. But inheritance is a real can of worms. First, I want to sort of paint the picture of inheritance as it's not trivial. It's not a simple abstraction. It's actually rather complicated. What's going on when you have your like animal, cat, dog, wolf or something? Well, you don't even know. So like schnauzer. Maybe your lion. What's actually happening is that you're creating a quite complex tree-like structure with, and if you have a complicated hierarchy, like a cheetah, you're actually creating quite a complicated data structure in your mind. And this is, what's really going on here is that each of these is a set of methods, right? And the methods propagate up this tree until they find an implementation. And that's not a simple thing. You don't always need a tree-like data structure to represent your program. Oftentimes it's just completely unnecessary. You'll find that object-oriented programming, as defined as inheritance, just adds a ton of boilerplate and doesn't really solve your problem. It just adds stuff. It adds code. It adds, it adds complexity that you really don't need to solve your problem. So inheritance is taught in CS classes as a sort of classic sort of hammer that solves all problems. It's a sort of a one-size-fits-all, but I would say it's a one-size-fits-one size. It's not a problem that, or it's not a solution to every problem. It's a solution to some problems, and most of those problems that's a solution to relate to extremely large teams, extremely large projects. And even then you can argue that it's not exactly necessary in all cases, and all small and all large teams are all large organizations. So I don't think that object-oriented programming is necessarily bad. I don't think you can call anything bad or good in this world of programming, but you can call it heavy. It's a heavy level of abstraction that oftentimes isn't needed. They say compose over inherit. So this has been known for years too. It's been known since like the 90s. You rarely need to inherit. Most of the time, if you just put objects together, if you just nest some data together, that's all you really need. You don't need inheritance and methods and all that stuff. It's generally, again, you don't need it. You just use an if statement. You just use a switch statement. It's not giving you something that you can't get elsewhere and more simply elsewhere. All right, fourth tip. Move from concrete to abstract. So what do I mean by this? I mean that in programming, I've found it most productive to start with no abstractions, or minimal abstractions. This is almost a superset of the last tip. Object-oriented programming is just one of many possible abstractions. But what you'll find is that most abstractions are actually added complexity. Like, think about that for a second. That's what abstraction promises is simplicity, is a clean interface to things. But oftentimes, it's just a layer of indirection for something that you aren't really adding functionality to. You're just adding a layer of indirection to remove functionality. So what I mean by that is, say you have a function like function A, right? And it does some stuff, right? It does some stuff, sure. But if it only does, say, like, okay, the stupidest abstraction I can think of is add, right? Okay, so A, B, C, A, B. Return A plus B. You could say, oh, this is a clean interface on top of addition, right? It's a function now. But you've really done nothing except add a layer of indirection. This is a stupid example, but a lot of abstractions that you write, that other people write, tend to look something like this. You know, it's not really adding simplicity. It's not really adding ease of use. It's just a more roundabout way of doing things. So you have to be careful that your abstractions actually do something. And more importantly than all that, more important than that rant, I'd say your initial abstraction, your first pass at trying to abstract everything, is probably terribly wrong. Terribly off base. Abstractions tend to emerge naturally out of patterns. So a good abstraction sort of sees a pattern and then runs with it and then generalizes it or is able to encapsulate it somehow. That's not necessarily a bad thing. But if you try to do all the abstraction up front, you're going to run into some problems. You're going to realize that, oh, wait, I didn't account for that case. Well, now I have to redo the entire thing. That's why abstractions should flow naturally from your code. Flow naturally, or emerge might be a better word. Emerge naturally. You don't force them. So object-oriented programming, then, in the context of this tip, is really an extremely forced abstraction. There's no right or wrong abstraction for things. And that's what makes it hard. It's sort of a judgment call. There's no real objective measure for whether an abstraction is better or not, or worse than another one. That's what makes this such a difficult task, and that's why programming is hard. All right, that's one of the many reasons why programming is hard. Last tip. Actually, I have several more tips. I forgot what tip number 1. I'll just say 5. Don't learn frameworks. Learn languages. So this kind of goes back to my tip about the spectrum of, or the trade-off between pulling libraries for everything and reinventing the wheel. One other downside to being too lazy is that you never really learn anything. It doesn't become, learning how to use the API for one library doesn't necessarily translate into learning the API for another library. But if you're able to learn the language, one easy way to learn a language is reinventing wheels. Reinventing wheels is a great training exercise, by the way. Learning a language first can make it extremely easy to pick up libraries. So what I mean by that is, say the time it takes to learn a language, say JavaScript. Say it's 100 hours. Okay, from scratch. And now say the time to learn React, say. Okay, there's going to be a bit more than 100 hours. It's probably going to be like 200 hours, right? Because you have to learn JS plus React here. Whereas if you first learned JS, then React, maybe it's only 150 hours. Because when you say, oh, I'm going to learn a framework and you don't know the language previously, you end up having to learn the framework and the language at the same time. Whereas if you just learn the language, I think it becomes quite a lot easier to pick up APIs for frameworks after that. I mean, I could be totally wrong about this. This is just in my experience. If you want to quickly pick up a framework, the easiest way is to first learn the language. All right, sixth tip. Be careful where you get your information. Just right, be careful. It's very easy to find programming answers to questions online that are frankly subpar, and it doesn't make me feel good to say this, but I think that in my experience it's been true. And it's hard to find good answers to questions. And sometimes this is due to, underqualified people answering questions, but also it's due to you as the asker not really knowing what question you should be asking. So this also relates to the XY problem. Be careful of the XY problem and bad answers and bad info. So this is kind of two things in one, but these are related because sometimes falling into the trap of the XY problem, which I'll explain in a second, will lead you to bad info. So what's the XY problem? Well, I think we've all been there. I don't remember which one's X and which one's Y, but say you want to solve X, right? So you've tried Y, but Y isn't quite working. Isn't really working. So you ask about Y. So you ask why. So you ask on Stack Overflow about why. Well, that's your first mistake, because you really should have been asking about X. Sometimes your why carries hidden assumptions that are wrong, or maybe there's a really simple explanation for X that you were unaware of, and that's totally fine. Be careful of this problem, because getting on wild goose chases is disastrous. We've all been there. Stack Overflow, documentation, Stack Overflow. Like, it's a mess. So sometimes just take a step back, ask, what's the problem that I'm trying to solve here? Not, how do I perform this solution that I've possibly assumed to be the answer, but I don't actually know if it is or not. So yeah, that completes that tip. And our final tip is that test-driven development is ridiculous, but testing is important, and it's easy to neglect. So let me expand a bit on this. So what do I mean by test-driven development? Well, test-driven development is a rather new invention, and it sort of originates from the extreme programming era, pair programming, all these like buzzword era type things where you want to be as pedantic and as like comprehensive with your unit tests as possible. And this can even mean writing your tests as you write code, as a sort of way of interacting with the code, as a way of getting feedback. And honestly, that's not the worst thing ever, but it can slow you down. And unit tests for the sake of unit tests I've found to be really wasteful sometimes. You do want to test like that your program does solve the problem, but you don't need to test every single little function that you wrote. I think that that's kind of insane. So you want to strike a balance of test the business logic and, or unit test the business logic and then perform, larger integration tests on the entire program. And assign a well-architected code is this ability to separate the business logic from the infrastructure. And if you can, so testing in a way ability to test your code, or ease of testing is a sign of doing something right, on the right track. So if it's easy for you to logically separate your business logic and business logic tests from your high-level integration tests, that's a really good sign. If it's hard to do that, and you have to like mock, you're probably screwed. So if you have to mock, you're probably screwed. You might be screwed. Generally, having to mock is a sign that you've insufficiently sort of gapped your layers of abstraction. So. Well, also, sometimes mocking happens when you object-oriented program too hard, and you go into like singletons and shit, and that's just a disaster. Point is, testing is really important. Don't slack on your testing. So do test. You don't have a program if you don't have tests. But you don't have to be insane about testing every single function. Like, I think that's counterproductive because why is it counterproductive? Well, you don't want to waste time. Okay, now here's why. It's because of the weight thing I was talking about earlier. A test can carry weight as well. You need to maintain your tests. You need to make sure they all pass, blah, blah, blah. So if you test every little helper function in your program, well, that's going to be weight. And that's all I have to say on that. So yeah, that completes the video. I hope you learned something. Take care.